Okay, let's go to Matlab. I'm going to assume that you can find Matlab on your computer and load it up. When you load it up, you're going to see some combination of what you're seeing right here. Mainly, what we're going to be using is this main window here, and then this other thing, the editors on the side, will be my little cheat sheet for what we want to do here. I basically just want to walk you through some of the things with Matlab, just in case you've never seen this before. So let's start here. So this is the main workspace of Matlab. And Matlab, unlike if you've done any C programming or Java or anything like that, Matlab is a scripted language. And what that means is that Matlab will execute the code line by line as you write it. So you don't have to go and compile or anything like that. You just type in what you want to do. For the most part, Matlab is pretty smart about setting up things. So for example, if we want to declare a variable x equals 5, again, for those of you that are familiar with C or things like that, you'd have to declare x to be an integer, a double, or whatever. Matlab doesn't care. It's going to declare it whatever it needs to be in order to be x. So if I type x equals 5, it says, well, there you are, x equals 5. You'll notice that over here in the workspace, this tells us what variables are stored. And so now the idea is that now that I have x equals 5, I can use that in the workspace whatever I want. So now I can say y equals 500 times x. It stores that value of x, and so now y equals 2500. And again, it's going to store that value of y, as you can see showing up over here. So the idea with Matlab is that the name is an acronym, Matrix Laboratory. And so what that means is that Matlab is really good at creating arrays. And the standard way of defining that is we can say x equals 0 to, and we'll say count up by 4s to 100. Now you can see that it gave us every value of 1 through 100. So x is now a 26 element array. Now, here's the nice part. I can still do the same things I was doing before. Y equals 500 times x. And again, for every value of x, it multiplies by 500 and get a new value of y. And so now you can see we can create arrays of things pretty easily. Another thing that we can do here, if we come back to x equals that, we can also just do this. I'll go by 5 just to show that it's different. If I put a colon at the end, then it doesn't spit the answer back to me. It just stores it, and you can see now x is a different length. If I want to see what x is, I can just type x, and then it's going to tell me. So that's sort of one thing that we can do with Matlab, is allows us to create things. The other thing, it has very nice sets of display capabilities. So for example, if I want to plot, let's go back here. I have y equals, instead of it y equal, let's do it this way, x equals 0.01 to 2 times pi. Pi is a stored variable in Matlab, and so it will give you the exact, well, obviously not the exact, but it'll give you the value of pi if we stick it in there. So x is now an array from 0 to 2 pi. Now if I say y equals the sine of x, now what I can do is I can plot this. Here, I'll do it the full way. Figure 1 allows us to pull up a particular figure, and that way we can keep referencing that same figure. CLF clears a figure, and then we can do plot of x comma y. So x is going to be the x-axis, y will be the y-axis, and lo and behold, there we are. Oh look, it's a sine plot. And you can see x is along the bottom, y is along the top, and we can do things, we can create labels and things like that. So let's jump over to our script. Because again, we could do everything we want to do in Matlab and type things line by line. That gets a little old, especially if we want to go back and tweak things. And so one of the strengths of Matlab is to be able to create scripts. So coming over here, this is our editor window. And again, depending on the application you've got, you may have a different approach here. So if you look at in terms of how the editor window is set up, if you create something at the beginning, so I type blah, blah, blah. If I try to run this, Matlab doesn't know what blah, blah means. It doesn't like that. But if I put a % sign out front, you notice it turns green. That's a comment line. Matlab won't read the comment lines. So what clear does is it erases all parameters. So if you go back here, if we type clear here, look over here in this corner and see what happens. See, all of our workspace got emptied out. I strongly recommend that you put clear at the beginning, because sometimes what you'll do is you'll be changing variables and then you'll rerun the program. When you rerun the program, it does not automatically clear. And so sometimes things get screwed up because you've forgotten to change or you've played around with array size. So I always recommend using clear at the beginning of your script. Then I'm setting time from 0.1 to 10. I'm creating a variable for g0. This is also, put it this way, good practice, meaning not that you should try it over and over again, but this is a good approach to doing programming. The reason is that, first of all, I've defined the units and I've defined this variable. If I need to change a parameter, I don't have to go through and adjust all those variables. Or if I'm using gravity in lots of different places, and let's say I'm going to switch from metric units to English units or vice versa, I don't have to go through and make sure that I've changed all the variables. So this is a good debugging method because I can see where g0 shows up in places. It's also a good error reduction method because I don't lose decimal places or things everywhere else. So MATLAB does for loops like most programming languages, so this is how we do it. For I equals 1 to the length of time. One thing you'll note here, and in fact one of the things I would suggest you do whenever you're looking at this, notice that I just defined this variable length, or this parameter. Well, how did I do that, or where did it come from? Let me come back over here for a second. MATLAB has lots and lots of built-in functions. As you saw, sine was a built-in function, figure, clear up, plot, things like that. For just about anything in MATLAB, you can type help. So for example, help length, and it tells you what that variable or what that function is. So length returns the length of vector x. So what I'm doing is I'm creating, and again the reason I've done it this way is I can come back and I can change my time to be whatever I want, and then this system will automatically update. I don't have to go and change this value for every time I change the length of time. So what I'm doing is I'm setting the value of x at each point based on this function. X equals g0 times the sine of time plus time squared, just to stick something in there. Some other things to point out. Since I'm inside the loop, time of I is just going for array number 1, 2, 3, 4, the elements in that array. And this is how you do, oops, I keep hitting the wrong button here, sorry. This is how you do exponents. So this is going to update the value of x as a function of time. Then it's going to plot it, and here's some other things. Grid on will create a grid. This is how you set labels and titles. And then we'll talk about this axis thing and the text thing in a second here. So let's go run this. Now, a couple different ways to run it. You can come over here to this button and push it. You can come over to under debug, run configuration, or save and run. I'm usually going to do this one. Again, this is a Mac. Your mileage may vary. So if I run it, what happens is it loads this into the workspace. And let me go ahead and for the moment let me comment out those things, run it again, show you what's going on. So here's my awesome plot. You can see the grid is on and it's plotting this thing up and down like this. Now one of the things that you need to do in the homework assignment is you need to restrict the range that you see the plot, and that's what this axis comment does. Come over here, and in fact axis can do a million different things depending on the way you set up the parameters. See, there's lots of different things here. We're actually using one of the first ones in a row. So coming back, if I put axis, and you see that I have these parentheses and these brackets inside. So this is the minimum x value, this is the maximum x value, which I take to be max of time. I'm going from 0 to half the maximum value, just because those are the range that I wanted to set. So if I run this, now you can see that it goes from 0 to 10, which is the min to max time, 0 to 10. And then it goes from 0 to the maximum value of x over 2, or halfway up, which was around 50 in this case. So here you can restrict that range to display whatever you want. And you'll notice that you can stick functions inside here. This is again one of the other nice things about MATLAB, is that you can stick function results wherever you want inside. And then this last thing here, this text, allows me to place text on the graph at a particular point. So this is going at position 5/50 and then the word text in here. So if we run it, you can see it's kind of hiding up there. So let's change this to 45. So 5 and 45 are the units of the plot, based on however we defined it in the first place. So there's my text. 5 over, 45 up, right there in the middle, boom, there's the start of my text. So if I want to put labels on the plot, this is one way to do it. Now, that in itself is useful, but two things I want to show you. The first is here. As it turns out, there's a faster way to do this in Matlab. So I'm going to take this, I'm going to copy it. Oops. Then I'm going to comment out this. Matlab is actually designed to go very efficiently to multiply in matrices and do matrix operations all at once. And so if I do it this way, there's one other thing. So now I just take G0 times the sine of time. And so I'm taking the sine of everything in the array and I'm multiplied by G0. Since this is a scalar and this is a array, the scalar just multiplies by every element in the array, everything's fine. But over here, if I take an array and I square it, weird things happen in MATLAB depending on how things are laid out. So what we do is we put this little period out front. What the period says is that we're doing element by element math. And so I'll put it over here, element by element math. So this will do the exact same thing, but it will do it a little all at once. And just to show you that it really is working, I'm going to put this in figure 2. So this is my new figure, which as you'll see is exactly the same as the old figure. Again, it's hard to see right here, but this is actually faster. It takes less time to execute than the other version, and it's also a little bit cleaner in terms of I don't have a for loop or things like that. So for loops work just fine, and I'm definitely not grading you on the cleanliness of your programming. So however you want to get to your solution, as long as you get there, is fine with me. But I just wanted to show off a couple of things. Other thing I want to show off is the idea of a function. Because, as I said, you can stick these functions in places, the sine or other things. We put max of time in here. We can write our own functions, and that's one of the real powers of MATLAB. The way that you define a function is you put it out, you put in that first line function. Then you put your output variables. You notice you can have more than one output variable in MATLAB compared to lots of other programming languages. And again, you can have multiple inputs as well. And so I'm calling this eSci211 demo function. That has to be the name of the file. MATLAB will fuss at you if you don't do it that way, so make sure that you make sure it's, and so these are the input variables. So now my time is going from 0 to Tmax. G0 is being specified, so I've commented that out. I'm doing the exact same thing I was doing before, and then doing the plot. And again, all of the restrictions that we had on there before. So if I come over here, if I want to call this function, and again, I can call it from another script or another function even. I just type it in this way. Oops. Demo function. And going back here, first was Tmax. And I'll just do it 10 and a G0 of 32.2, just so we have the same thing. I'm going to put the colon at the end because I don't want all of that output to be spit out at me. So now you'll notice the big deal here is that time and x are now in the workspace, and so I can use them other places. But I could also now go in here and set the gravity to 40. We get a slightly different value in here. I could set it to a value of 1. You can see that the scale looks very different here, depending on what's going on. So we can run this for more time. And on like that. And I think you get the point, so I won't belabor it. So there's lots of different versions of that same plot. Let's see. I think those are the main things that we want to show off for now, was mainly just how to create functions, how to create scripts, so you save them in their own files, ideas of comments, for loops, multiplication. And if there's any questions, feel free to send me questions, and I can create more of these demos if we think that they would be useful.